Hi, everyone. Welcome to the video part of week 2's lecture. And so the topic we will tackle today is the truth of complex statements. So here's a refresher on what we did in week 1. Remember that we saw one possible but useful way of parsing statements. We might parse them with objects and predicates. Remember that the objects refer to things in the world, whereas the predicates characterize the object. And we saw simple statements, we went over them, and we saw that those statements are those that have only one predicate. They may have many objects, because remember, predicates might have, they might take in multiple objects. And we saw that simple statements are true just in case the characterizing expression correctly characterizes the object it is taking. So if I say the cat is on the couch and the cat is not actually on the couch, then that means that the predicate is incorrectly characterizing the expression, and so the statement is false. But things get more complicated with complex statements. Remember that complex statements are those in which you have the logical connectives and, or, and not. And the question of when are complex statements true becomes more complicated, because the predicates and the objects must be combined in a certain way. Which way, you might ask? Well, this is what this video is about, and we'll get into it. So remember the simple statement, Po is on the couch. We saw last time that this sentence has only one object, namely Po, the cat, and one predicate, namely is on the couch. And with the logical operators not and or, we can create more complex sentences. So what do we mean by that? So what we mean is that we can take this statement, Po is on the couch, and say Po is not on the couch. So now we see that there's a not in the statement. We can also combine two simple statements by saying Po is on the couch and Po has green eyes. Or we can say Po is on the couch or he is on the carpet. So let's say a little bit about these logical connectives. Note that they don't refer to an object, right? It's not that not refers to something in the world, nor does and, nor does or. But note that these logical connectives also do not characterize the object in any way. Rather, what they allow us to do is to create more complex sentences from simpler elements, namely from simpler statements. And the question we're going to be interested in is, how does the truth value of a complex statement depend on the truth value of its simpler elements? And this is what we're going to see. So let's look at how we will construct truth tables, because this is how we're going to really see how the truth values of these complex statements. So let's take the simple statement, Po is on the couch. And let's just note the statement by P. There's two possibilities, right, for P, or that statement. It can be true or it can be false. And this is what I'm denoting here on the right. So it can be true when Po is actually on the couch, right? It's true, and you can see that I highlighted in the table the T. Or it can be false. Po might be on the ground, rubbing his back. And if I say Po is on the couch in that case, then the statement P is false. Right? Nothing crazy here. So what about the not? How can we put that in? So again, we'll take our simple statement, Po is on the couch, and it's true in this case. And if we say not P, then that will become false, right? If it's true that Po is on the couch, then Po is not on the couch, which we denote with this dash or also a squiggly line in the book. then that sentence, that complex statement, not P, is going to be false. This should be intuitive, right? This is just a fancy way of writing. For example, if I say the sky is blue, that's true. And if they say the sky is not blue, then that's false. Now here's a note. Remember that there's many ways, this came up in lecture, right? There's many ways in natural language, so in everyday language, of expressing the same thing in logical language. So for example, these two statements are logically equivalent. It is not the case that Bo is on the couch and Bo is not on the couch. Like these two, you can translate them logically in the same way. Okay, so let's look at a case where the statement P is false. So just in the picture I showed you before, Bo is on the ground, I'm rubbing his back. So if I say Bo is on the couch, then this statement is false, right? And I denote that with an F. And similarly, if I say not P, then we just go through the opposite, right? It's going to be true. If I say Bo is not on the couch, so not P, then that becomes true. Similarly, if I say the sky is green, that's false. But if I say the sky is not green, then that statement is true. So let's look at the truth table for the not, if with just one statement, P. This is the whole truth table. You have P and not P, and this is how you read it. When P is true, then not P is false. And when P is false, then not P is true. Right? And this exhausts all the possibilities, right? Because P can only be true or false. And therefore, we need to look at the truth value of not P when P is true, and the truth value of not P when P is false. And that just gives us 4 overall possibilities. Okay, so we went over the logical connective not. So let's look at the second logical connective and. And it's denoted by this sign. So let's take again a simple statement. Bo is on the couch. But now we might have another simple statement. Bo has green eyes. And we want to combine them in a certain way. So I might want to say, well, Bo is on the couch and has green eyes. Right? This is the same as saying Bo is on the couch and Bo has green eyes. And we denote this by P and Q. And now I want to ask you, what's the truth value of P and Q? And truth tables are going to become very useful here. So let's look at all the possibilities. Let's look when P and Q are both true, right? Bo is on the couch and Bo actually has green eyes. In this case, I've said 2 true things and I've put them together in a conjunction. And so the sentence, Bo is on the couch and Bo has green eyes, is true, right? And this is actually the case, I think. But there's another case. There's a case when Bo is on the couch, but Bo does not have green eyes. Right? And then you might ask, well, is that sentence true or false? And so the 2 parts of the conjunction, we call these the conjuncts, right? P and Q. There's one that's true and one that's false. Here, Q is false. And when one of these is false, then the whole conjunction is false. If I say Bo is on the couch and has green eyes, and Bo in fact has blue eyes, then that statement is false. Similarly, if I say if Bo is on the ground and Bo has green eyes, then still one part of the sentence is false, and the whole sentence is false. And the last possibility is if both parts or both conjuncts are false. If Bo has blue eyes and Bo is on the ground, then P and Q are false. And if I say Bo is on the couch and Bo has green eyes, it's false and false makes a false. This might sometimes not be super intuitive, but it's just something you have to learn. And it's kind of how we define truth values in a way. And this type of logic is what you use, for example, in mathematics. So let's look at the sentence, Beau is a cat and France is in South America. And I ask you, is this sentence true or false? So you'll notice that there's an and there. So let's look at the two parts of the conjunction. We'll look at Beau is a cat, right? There's two possibilities here. And let's look at the second part, France is in South America. We know that's false, and there's two possibilities there. And so it's the second line that we're interested in, right? Where P is true and Q is false, because that's our sentence. And so P and Q we saw is false. And so the statement is false. Now you might have noticed that when we looked at the truth table for the negation or for not, then we only had 2 by 2 square, because then we were only considering one simple statement and we were negating it. But here we're dealing with two statements, right? We're dealing with P and with Q. And now we have 4 possibilities, right? P can be true, P can be false, and Q can be true and Q can be false. But when we combine them, then we get 4 possibilities, right? It can be true, 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 false, false, true, or false, false. Okay, so let's look at the last logical connective, which is or. And it's denoted by this little V sign. So let's use the same statements. We have Beau is on the couch and Beau has green eyes. And I might ask you, well, is Beau on the, well, I might say the statement, Beau is on the couch or Beau has green eyes. And this is how we translate it, P or Q. And let's look at the truth table for that. So we have the statement P. Let's say it's true. Let's say Beau is on the couch and Beau actually has green eyes. That's a real condition. Then we call this a disjunction. Is this or sentence true or false? Well, both are true. So the statement as a whole is going to be true. Note that we're not saying either Beau is on the couch or Beau has green eyes. We're just saying Beau is on the couch or has green eyes. The either would imply that only one of these is true, but when we use the logical or, both can be true, and the statement as a whole will be true. So this is the same truth value as the and, when everything's true. But now what if I tell you, well, Beau is on the couch or Beau has green eyes when Beau in fact has blue eyes? Well, now with the or, all we need is one part of the sentence to be true for this whole statement to be true. Okay, so and this should make intuitive sense, right? If I say, well, either without the either, I say the sky is blue, or I am 15 years old. Well, I'm not 15 years old, but the sky is blue. So one of these is true, so the whole statement is true. And the same thing when you have P being false and Q being true, right? The whole statement is true. It's still one part is true, so the whole statement is true. And so there's only one case where the disjunction is false. It's when both of the disjuncts or both parts are false. So if I say the sky is green and Irvine is in Alaska, or Irvine is in Alaska, well, both of those are false. So the statement as a whole will be false. So let's look at a variation of the statement I gave you before. So Beau is a cat or France is in South America. Is the statement true or false? And now we have the tools to examine. Let's look again. So Beau is a cat. There's two cases in our truth table where P is true, right? The first and the second line. What about France is in South America? Well, that's false, and there's two places in this truth table where Q is false, and we're denoting France is in South America by Q here. And so we're in the second line over here, and P or Q is true, So the statement boys in South America or France, sorry, I'm getting confused now. If I say boy is a cat or France is in South America, then this statement is true. And what logic allows us to do, these truth tables allow us to do, is to look at the truth value of any complex statement, because they're all constructed with not, and, or. So now I can ask you, let's construct together the truth table for P or Q. And note that P, not P or Q is not the same as not this whole thing, P or Q. So having said that, maybe you should pause the video now and try to construct the table yourself. And if you can't do it, then come back and that way you can check where you've gone wrong. Okay, so hopefully you've paused it and now you've come back to it. Hopefully you've succeeded, but now just to check your answer. Let's construct the truth table for not P or Q. Right, this is quite a complex sentence. We have not P, and then we have a disjunction of not P or Q. So this is how we start. We take the simplest elements we have and we give out all the possibilities. Right, this is the same thing we've done before. So P can be true or it can be false, and Q can be true or it can be false. And combining these, we have these four possibilities of true, 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 false, false, true, and false, false. Now let's take the second simplest element in a sense, this not P. Well, we saw that not P is, when P is true, then not P is false. And that's what I've designated here, right, in the top two parts of the table. Note that here, the P is true in the first two lines, and so not P is going to be false. And similarly, in the last two lines, P is false, and so not P is going to be true. And now we actually have all of the tools to look at the truth value of not P or Q. So let's, right, we have Q and we have not P, and we just have to put them together. The order shouldn't matter, right? Maybe that's something I should say, is that the order doesn't matter for either the conjunction or disjunction. A fancy way of saying that is that they're order invariant. And so let's look at this first case when Q is true and when not P is false. Or not P is false because P is true. And so we have these true. So we have a true or false, and true or false is true, right? Remember we saw it, and you can look in your book. True or false is true. Similarly, what about false and false? Well, a disjunction is false only if both parts are false, and so this part is false. And now we still have two cells to complete. Try to do it if you were stuck before. Okay, now we have the case where both parts are true, right? Remember, is Po has green eyes or Po is on the couch? They were both true. That's true. And this is the same as the first line, only inverted, right? Q is false, but not P is true. So false or true is true. And we've completed our truth table, and that's it. And that's how you construct a truth table. You take the simplest statements, you write down all the possible combination of truth value, and then you slowly build it up. Okay, so I hope this gave you a nice introduction to the truth tables. I will also link to some videos on the Canvas, not made by me, but that can be quite helpful. And as usual, please come to office hours if you have any questions. And thanks.